Hello and welcome! This is the first of 3 extra chapters that we've added to the course covering CDI, or Context and Dependency Injection. In this first part, we'll go back and review classic dependency injection that we used earlier in the course. I'll talk about why some people were not happy with it, which is why a new and upgraded form of dependency injection, called CDI, is now available. We'll see that you can run CDI standalone, that means outside of Glassfish, and that's what we will be doing in this chapter. CDI gives more flexible features than the original classic CDI. And we'll study one of those features, which is called Defaults and Alternatives. Well, Java EE is a huge topic, so we couldn't cover everything on the course, but we did want to hit all of the major topics. When we recorded the course, version 6 was the current version, and we aimed to cover every topic that we believed that all Java EE developers should know. Since the course, Java EE 7 was released around 2013, and really it didn't change very much. A lot of the APIs that Java EE covers were upgraded, which meant that minor improvements became available. As a quick example, in Java EE 6, you only get JPA version 1. In Java EE 7, the JPA is upgraded to version 2. But it's not really a massive change. JPA 2 simply contains a few extra features that didn't make version 1. These extra features might be important to some projects, but the new features did not change the basics. One example is that JPA 2 features locking, which you were not able to do in JPA 1. It's really an advanced feature, but if you're really interested in that, we do cover it on our full JPA training course. Anyway, what's great is that everything covered on this Java EE course is still valid, relevant and useful today. But there was one topic that we did not cover on the course, and that's called CDI. Now, CDI was present in Java EE 6, but it was brand new, and at the time of recording, we didn't know whether projects would be using it or not. But now that I'm recording this extra chapter in 2014, we now know that many projects around the world are using this new library from Java EE, so you need to know about it, which is why we've added this extra chapter to the course. So let's start then with the obvious question of what is CDI? Well, the acronym stands for Context and Dependency Injection. I'll come back to the context bit later on in this chapter. Let's start by focusing on this dependency injection part. You should know by now what dependency injection is. We covered this all the way back in chapter 5, when we first used this annotation here. I'm in the employee management class here, and there's my annotation, which is at EJB. And we use the annotation on our declaration of the data access object. If you've jumped straight to this chapter because you're only interested in CDI, then you will need to go back to the earlier parts of this course to understand dependency injection. But I'll do a recap just in case, and I realise that some of you might have done this course a couple of years ago now and might need a little bit of a refresher. So remember that in our project that we've worked on, we have 2 classes which are very dependent upon each other. We have this employee management implementation class, which we're using as a kind of a friendly interface to our client applications. And I was calling this a service class on the course. Now, we decided that we didn't want to put any data access operations in this class directly, so we created a second class, this one here, called Employee Data Access. Or rather, we created an implementation of that interface. So here it is here. Now, clearly, our service class needs to be able to call this data access class. So we have a Java reference to that class right here. Now the problem is, where do we create an instance of that data access class? The obvious thing to do would be to hard code the creation of the DAO right here. We could have done something like equals new employee data access, which I guess would be the kind of thing that you would do on a very basic Java course. But the problem is, if we hard code the creation of the DAO here, then we get really hard coupling. It makes it difficult to work with the classes independently of each other, and we want to do that especially when we're testing, and it makes our life generally harder. In the very early days of Java EE, it was even worse. Often in this service class, we would do a JNDI lookup to get access to the DAO. Now that meant that the service class was now polluted with complex and unwieldy JNDI code. And it also meant that we could only run this service class if we had a JNDI server running. So that meant that we absolutely had to have Glassfish in order to even do a basic test on this class. So this was Java EE5's solution to the problem. Java EE5 introduced a very basic form of what's called dependency injection. With dependency injection, we just add this annotation of @EJB, and this tells Glassfish that when we deploy this class, it needs to search the application server for an instance of the data access class, which, because we're deploying the data access class as well, Glassfish will know it has to create an instance of that class. Because this annotation is present, then that tells Glassfish, or of course whichever application server you're using, it tells the application server that it needs to inject a reference of the data access class into this class. Well, I hope that's a reasonable recap of dependency injection. If not, then you can go back to Chapter 5 for full details of where we do this for the first time. So then, dependency injection was added back in Java EE5. I'm going to call this the classic Java EE from now on. And what I like about it is that it is simple. Once you understand what dependency injection is trying to do, it's really no effort to put in this 3-letter annotation into your classes. But lots of people weren't very happy with it. What's the problem? Well, I think generally it's just a very simplistic form of dependency injection. The number one problem with it is that this will only work for EJBs. Let's say we didn't want our data access class to be an EJB. After all, the data access class doesn't really need any of the features that EJB offers. We're not using remoting on this class. We're not using security. It doesn't really need to be an EJB. But if I were to strip it of its EJB status, and remember I can do that by simply removing the stateless annotation from the top, then I'm afraid I've now broken the system, because this injection will now not work. Now I must say it's not a big deal really, because adding the stateless annotation doesn't particularly make this class any more complicated. It might feel a bit heavier, it might feel like a slightly more complicated class, but really there's no great overhead in making a class at an EJB. But I think it's fair to say that being forced to make a class be a full-blown EJB just so you can inject it as a dependency feels a little bit heavy. You might remember that there are a few other types of objects that we can inject using the classic dependency injection. I might have mentioned earlier on in the course that in our data access class, if you want to access the database directly, and you don't want to go through an entity manager, you can get access to the underlying data source that you're using on the application server, and I would annotate that with the @resource annotation like this. And I'll just do the imports. And this will now tell Glassfish that when we deploy this class, it needs to take the data source that we're working with and inject it into this attribute. And I would do that if I want to access the database directly without going through an entity manager. So that's a form of dependency injection. You might also remember that back in chapter 12, when we were working on rolling back transactions, I showed you that you can enforce a rollback by making a call to the session context class. And we did that by doing dependency injection again using the @resource annotation. This version of the workspace doesn't have that anymore, but I'll just pull up a screenshot from earlier on in the course. And there it is, and you can see right there where we did the dependency injection. So there are a few things that we can do with this classic dependency injection, but they are limited. We can't do this with a regular plain Java class. Now, another problem that I have with the classic dependency injection is I think that these annotations aren't very clearly named. Let's have a look again at the reference to the data access object here. And really the annotation, if you didn't know, the annotation just sort of says, oh, well, this is going to be an EJB. It's not very clearly saying that this is an injection point where we're expecting an object to be injected. I've certainly, in the support calls for this course, dealt with quite a lot of people saying, I don't understand why I need @EJB on here. I think a lot of people expect @EJB to be on the top of the class, where you'd be declaring that the class is an EJB. I think it's fair to say that the dependency injection features in classic Java EE5 were a little bit rushed. Their development was cobbled together and sort of thrown into Java EE. And it was a little bit half-baked. My third problem that I have is that this dependency injection will only work with EJBs, and that means that it will only work on code that's running on the Glassfish server, or on whichever application server you're using. But if you compare that to other dependency injection frameworks in Java, and Spring would probably be the biggest one. Now, I know that many of you will have done Spring as well, and you'll know that Spring will happily run either on your local development environment or on your server. And that's a good thing because it gives us a lot of flexibility. To summarize then, I think this classic dependency injection is perfectly functional. It works and it's simple, but it is limited and not very well designed. It was kind of rushed into the spec. So the upshot of this story is that for Java EE6, the committee decided to add an extra framework called CDI, which you can think of as being a second attempt at getting dependency injection right. Now, the confusing thing for me is that the classic dependency injection is still there, it's still usable and still supported, and I'm still working on lots of projects in the real world that are happy to use these classic dependency injection annotations. But if you prefer, or if your project prefers, you could choose to switch to the new, improved and upgraded CDI. You can use both as well, I suppose. That would be fine. Now, this might sound a little bit daunting, but CDI is pretty simple as long as you understand what dependency injection is. So CDI really isn't exciting. You shouldn't expect any big dramatic features in this chapter, but you are going to get a more flexible dependency injection system. So let's get started and try context and dependency injection for the first time. What I'm going to do is I'm going to leave our full Java EE project for a short while. And what we're going to do is we're going to experiment with CDI in a really small basic project. And that small basic project will not be deployed to Glassfish. It's going to be a regular standalone Java program. Now, that is one of the improvements in CDI, that you don't necessarily need the full Glassfish container to make it work. So I'm going to temporarily, just to keep things clean, close the Java EE project so we know that's not going to get in the way. Now, if you haven't done so already, you can go to your Java EE course page on the My Courses link on the Virtual Pair Programmers site, the same place where you've downloaded all of the chapters for this course. And you should see a new zip file called CDI extra code. If you download and unzip that, you'll find in there a folder called CDI projects. All you need to do is copy that folder and then paste it into whichever folder is your workspace. If you're like me, you'll already have 3 existing projects, one called Java EE and those 2 clients that we wrote for our web services. So if you paste your CDI project into there, we can now go back into Eclipse and import the project in the usual way. My preferred way is to go to File, select New Java Project. Can feel a bit odd using New Java Project, but it's new to Eclipse. And you've got to be careful to type exactly for the project name the exact same name as the folder that you've just copied in. So that's CDI project, and you need to get the case correct. If you get that correct, then as soon as you type the final character, it will say here the wizard will automatically configure the JRE, blah, 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 and you should be able to click Finish. Okay, so the project's now open and we're ready to start working inside it. What I've essentially done in this project is I've created a very small cut down version of our employee management application, just so we can focus on just the CDI basics. So you'll find in there, for example, an employee class, which very cut down just contains the name of our employee. We have our employee management service interface, this time only with one basic method called getAllEmployees, and we have an implementation of that interface, which is going to delegate to a data access object, just like we did in the course, and the data access object is right here. Now, for this chapter, I'm not going to be calling the database, so I've hard-coded in 2 employees with some very dull names, which then get returned back to the service. So, as I say, I've done that just so we can focus on the CDI basics. None of these classes are EJBs or anything like that. So then, what I would like to do is I would like to make sure that our employee management service has a fully instantiated and working implementation of this data access object. At the moment, of course, this reference is going to be null, and we would get a null pointer exception if we tried to run this code. In fact, just for fun, let's try to do that. So I'll create a new class, and I'm going to call this one client, and I'll click the checkbox for generating a static void main method. Notice, by the way, that I do have a class in there called CDI client, which I'll be coming on to in a few moments. But in this client, I just want to demonstrate that because we're not doing any kind of dependency injection at the moment, if I was to create an employee management service, and I'll just call it service, and I need to instantiate the full implementation here. If I call service getAllEmployees, if I try to run that, yes, I'll get a null pointer exception, and that's because I've loosened the coupling between the service class and the data access object, but at some point, something has to inject the object into the service class. So the problem is that in order to make dependency injection work, we need to have some kind of a container that's going to instantiate all of the objects and connect them together. In other words, to perform the dependency injection. Now we're going to be getting Glassfish to do that in a short while, but as I mentioned earlier, it is possible to run a CDI application outside of the full application server. Now the way that this works is that on this project, I have in my lib directory a single jar file called weld-se. Now let me introduce you to what weld is. Now CDI, along with a lot of the other Java EE frameworks, CDI is a specification that anybody is free to produce implementations for. Well, it just so happens that weld is the name of the project that provides the reference implementation for CDI. Indeed, you're going to see shortly that weld is the implementation of CDI inside Glassfish. And what Weld have, and I've just downloaded this directly from their website, Weld have a jar file that you can use if you want to use CDI just in a standalone standard edition, that's the SE there, standard edition Java application. So earlier off camera I've written a proper version of a client application. Now this is a little bit awkward because unfortunately the details of how to write a client container were not contained in the CDI specification. So what you have to do if you want to write a standalone client application, and I've done nothing more than use the Weld reference guide here, you have to instantiate an instance of this class called Weld container. If you want to think of that as just being a very lightweight replacement for Glassfish, then you probably won't go far wrong. Now this line of code here is a little bit ugly. Again, I've just used the reference manual to work out how to do this, but effectively I'm saying to Weld, please give me an implementation of the employee management service. Once we've completed that line of code, then we don't need to worry about Weld anymore. We now have an instance of the employee management service that we can call and use. Now I'm not going to run this client just yet because it won't yet run. And the reason it won't yet run is if we go back to our employee management service implementation, the reason it won't yet run is that by default, CDI will not assume that you're dependency injecting everything. CDI has no way of knowing if our employee deo here is something that we want it to inject or if it's a regular attribute that we're going to be dealing with. The way that CDI works is, as you can probably have guessed, is by annotations. But the annotations are usually quite simple and lightweight. All we need to do to tell CDI that this is a dependency injection point is to include the annotation @inject. Now compare this to what we did on our full employee management system when we were working with EJBs. We had an annotation of @EJB here. So I can tell you then that the @inject annotation is effectively a replacement or an upgrade to the old-fashioned @EJB annotation. Now we are going to have to import that, so the usual Control-Shift and O, and check out the import. You can see it is coming from the standard Java packages. It's JavaX, which implies it's Java EE basically, and it is actually coming from the weld.se jar file. Now you might imagine that we've got to go and do lots of other annotations, but one of really the main selling points of CDI is that you don't need many annotations to make it work. You don't need to annotate the class, because what will happen when we run this code is that CDI will check all of the classes that we've got, and it will check for the presence of the @inject annotations. So that's, believe it or not, all there is to writing a CDI-based application. Now before I run this code, there is one final thing that we possibly need in a CDI application. And that is, you'll notice there's a folder called metainf under my source directory. We've used the metainf folder on the course before. It was the location for the persistence.xml file. But for a CDI project, we do sometimes need a file called beans.xml. Now, if you have a look in there, you'll actually find that there's nothing of real interest in there. It's just a schema declaration and no tags inside at all. And actually, you could even get away with this file being completely blank. which seems very odd, but I recommend that you keep what is in there because we are going to be expanding this file later and using it. But if you had a very basic application, you could leave the file blank. And it's a bit of an odd situation really with this file, that the file needs to be present, but it doesn't have to have any useful information inside it. Now, I understand that the later versions of CDI have dropped that restriction, so the whole file has become optional. But for some reason I don't quite understand. I do have the latest version of the weld jar file here, but our program will crash if there is no beans.xml file. So I don't quite understand why the file is necessary, but it doesn't matter because you're going to find in the next 5 or 10 minutes we're going to need this file anyway. This file will enable us to configure and tweak and just change the way that CDI works. So if you're happy with that, we can for now close the file and forget it's even there. Before I run the code, a quick review. We have our service interface, which we're implementing. We have a single annotation on there, which is telling, in this case, Weld, that we want it to instantiate an instance of the employee DAO and inject it into this class. The employee DAO remains a plain Java class. There's nothing special to do on that class at all. The slight problem with all of this is that in order to make it run, we do need a special client, and we need to work with this specific class from Weld called the Weld container. And we're going to use the Weld container to access our instance of the service. Okay, so let's do our first attempt at running a CDI application. Well, the big thing you'll notice there is that there is a little bit of logging coming from Weld. And I know it's in red text, which might look a little bit annoying, but it is only info warning, and there's actually nothing of interest in that red text at all. You could configure the logging to switch that off, but I'm happy to leave it in place. But the really good thing is that we didn't get a null pointer exception. We are seeing our two employees, A and B, listed to the screen. Just to prove that dependency injection was happening, I'm going to go into the employee management service and just experiment by removing the @inject annotation. So now Weld is not going to instantiate a DAO and inject it into there. So I think this time we will see a null pointer exception. We're still seeing the logging because we're opening the Weld container in the client, but yeah, we're getting a null pointer exception. So I think that's perhaps the most surprising thing about CDI is that you don't need many annotations to make it work. I've read quite a few tutorials for CDI online, and they seem to imply that you need annotations everywhere, but really, as long as you're not doing anything complicated, you don't need many annotations. So I've got my annotation back in now, and I'll just check that that's still running, and all is good. So now I'd like to look at one of really my favourite parts of CDI. It's very simple, but it's something that can have a very big payoff on full projects. And that's that we can very easily produce multiple implementations of an interface and switch between which one we want to work with at runtime. Let me give you an example. So assume then that our implementation that we have here is our production standard implementation of the employee management service. And of course, in real life, this would use databases and web services and whatever kind of real things we need. But that can be a bit of a problem in that in order to run the application, we need to have the database or whatever in place. It would be quite nice if we could have a sort of a testing version of the service that doesn't use a real database. And that means we can spin up the application far easier without having to set a database up, and we could easily test the front end, for example. So that's quite a common thing to want to do in Java applications. You're probably very familiar with doing that. And it all spins around working with multiple implementations of the same interface. So let's do that. I can create a new class. And I'm going to call this the employee service testing version. The key thing is it needs to implement the interface of employee management service. And I'll make sure that the inherited abstract methods is ticked here, because that will create a skeleton implementation with all of the methods already in place. Now for this testing version, my other one used a data access object, but this one is just going to return some hard-coded data. So I can just create a list, a simple array list of employees, and I'm going to add to that return list. Now, of course, it's slightly false this because my production standard implementation is also returning hard-coded employees, but I hope you get the idea. This one really is a genuine hard-coded version. So I'm going to send back an employee, and we'll use the name test employee 1, and we may as well add another one while we're at it. That can be test employee 2, and I will return the return list back to the client. I have a bit of a warning there because I forgot to put a type on the list there. And I need to import the ArrayList class as well. So that's good, that's compiling. But now the problem with that is if we now run the client, I have a rather nasty looking crash. It should be quite easy to understand this. The key word here is ambiguous, really. It's saying that Weld cannot resolve an ambiguous dependency. And what it means is our client, or rather our CDI client, is saying, okay, Weld, please find me the implementation of the employee management service. I didn't look in too much detail at this before, but it's worth pointing out that usually in CDI we work with types. CDI aims to be a type-safe dependency injection framework. So I'm saying that I want an implementation of the employee management service. And of course, Weld is saying, well, I have two of them. I have the production standard and the testing version. I don't know which one you want me to work with. Now, there are various ways of specifying here in the select exactly which one we want. But there is a far more elegant way of doing that. And that is, if we go into our production standard implementation, we can tell CDI that we want this implementation to be the default one, the regular one that we want it to work with. And the annotation is beautifully readable. It is just at default. Of course, it will need importing. And again, you can see it comes from the JavaX packages. Whereas our testing version, the one here, we want this to be a kind of alternative version that we occasionally use only if we specifically ask for it. How do we do that? Well, again, the annotation I think is really quite lovely. The annotation is alternative. And I will import that. So I think one of the main design goals of CDI was to make these annotations quite readable. I think that works really well. CDI will now know that this is the one that we usually want, unless we want it to explicitly use something different, in which case we can switch on one of the alternatives. Now, I'll show you how to switch on the alternative in a short while, but first let's try rerunning the client. And yet now CDI knows which one to pick by default. So the next question then is, let's say we do want to use the testing version. How do we make that happen? Well, there are a couple of ways, but the main way is to use the beans.xml file. And all we have to do in the XML file is to add in a tag. And the tag is, and I'm being helped by the IntelliSense here, the tag is alternatives. And inside that tag, it's very simple. We just have to provide the tag called class, and then the fully qualified name of the class that we want it to use as an alternative. Now, we don't have packages on this project, but we would normally have a package followed by the name of the class, which for us is Employee Service Testing Version. And this now means that when CDI starts up and does its dependency injection, this kind of promotes this class to be more important than the at default. So this time around when I run, we're now seeing the testing version in use. Now, I don't know how you feel about that. You might think it was a bit awkward to have to go into an XML file and to type in the name of the class, but I think this gives you wonderful flexibility. In this specific example, where we sometimes want to use the testing version and sometimes want to use the production version, it really is just a case of switching the XML file. So you might have one version of beans.xml for testing, which would be this one, an alternative version for production, which would be the empty one, in which case it would work with all of the defaults. And then as part of your build process, you could just switch the two around. And we're going to do exactly that kind of thing when we go back to our full Java EE application. And really, that's it for the basics of CDI. There are a few other annotations that we are going to look at in a short while. And there's also improvements to JSF that we need to study, and we also need to understand what the C part of CDI is. But for the dependency injection part, that's really all there is to it. So we've now established the basics of CDI. Not exciting, but still useful new features. I think the most confusing thing is that there is already dependency injection in Java EE, and it's been there for a long time. But this classic dependency injection is a bit weak, and people felt it needed replacing. So CDI is the replacement, and the first feature is that it also works in non-Java EE applications, so we've been able to test and run CDI outside of Glassfish. The first feature that CDI offers is defaults and alternatives, something that wouldn't be easy to achieve using classic dependency injection. Well, that's the basics, but this is a Java EE course, so you'll want to see how we can use CDI in our real Java EE application. So stay tuned. In the second bonus chapter, we'll run up our employee management system and we'll use CDI in there.